Did you know that OpenAI's newest model actually performed worse on some tests than their previous versions? OpenAI spent 10 times more resources on GPT 4.5, but people preferred the older model in blind tests. In this video, I'll break down what this shocking development means for the future of AI and why we're witnessing the end of the just make it bigger era. The next breakthrough in AI won't come from where you expect. I'm Evan Goldstein. I'm a licensed professional engineer and a data scientist. I'm building AI Capitalist to talk to the leaders and the thinkers, like you, about navigating this new world of thinking machines. So the way that we're doing artificial intelligence right now probably won't get us to a point where machines are as smart as humans. At least that's what a bunch of experts are saying. They asked 475 AI researchers, and 76% of them think it's pretty unlikely that just making large language models, or LLMs, bigger will lead to artificial general intelligence. That's AGI, which is that dream scenario where machines can learn like we do, or even better. Despite the hype, since the AI craze kicked off in 2022, where everyone thought more data, hardware, energy, and cash would make AI outsmart us, these experts are basically saying, not so fast. Now, this comes from the AAAI 2025 Presidential Panel Report, which takes a look at the fast-paced world of AI research across 17 key areas, like how machines reason, how trustworthy they are, and even how they affect the planet and politics. And the report points out that the big shifts are happening as corporate research labs, with their mega computing power, take over from universities in doing the cutting-edge development. It's making it harder for universities to keep their top talent and to stay in the game. So with the latest models not really bringing much new to the table, most of the researchers surveyed by the Association for the Advancement of Artificial Intelligence think that tech companies have hit a dead end. Let's look at ChatGPT 4.5, the newest model. A lot of people have mixed feelings about it. Some say it's not all that, and others think that it's got better emotional intelligence and creativity. But one thing everyone can agree on is that it's pricey. If you ask me, ChatGPT 4.5's results hint at something bigger than just what it can do. Its less than stellar performance might mean that we're hitting a wall with train time scaling and opening doors to new AI ideas. Now, in the past, OpenAI's models have shaken things up and set new benchmarks. But this time, it brought some cool tweaks to previous models, but most people are like, it's okay. The vibe I get is mostly just meh. OpenAI hasn't spilled much about how they trained this model, but they've mentioned it's massive, but it's not a major upgrade. Andrej Karpathy, who was on OpenAI's founding team, noted that each 0.5 version means about a 10 times boost in pre-training compute. The pricing backs this up too, and it's hefty, with API costs at $75 per million input tokens and $150 per million output tokens. So what neat upgrades does this costly model bring to the table? We're going to start the slideshow.
These two charts tell a straightforward story about how different AI models handle information. On the left, we see the accuracy chart, which measures how often these AI systems get their right answer when asked simple questions. Think of it like a test score. GPT 4.5, which is the green bar, is scoring about 62.5% correct answers, while other models like GPT 4o and OpenAI o1 score lower. The tiny OpenAI o3 mini model only gets about 15%. Imagine getting just 15 out of 100 questions correct on your history exam. On the right side, we see this hallucination rate, which is basically how often these AI systems make things up or give false information. This is like measuring how often someone in your class confidently states something that's completely wrong. For hallucinations, lower is better. You want your AI to admit when it doesn't know something rather than making up an answer. Now, GPT 4.5 performs best here too, only hallucinating about 37% of the time, while the smallest model, O3 Mini, makes up answers over 80% of the time. It's like having a friend who only makes up stories 37% of the time versus another who's inventing things 80% of the time. You'd probably trust the first friend more. And now looking at this table comparing different AI models is really eye-opening. It's like when you spend a fortune on the latest smartphone, only to realize that your friend's cheaper model actually takes better photos. GPT 4.5, which is supposedly the newest and most advanced model, isn't actually winning across the board. In fact, That smaller O3 mini model absolutely crushes it at math, 87.3% versus 36.7%. And it even beats it in science. That's like the varsity quarterback getting outperformed by the freshman that nobody even noticed. What's really striking here is that GPT 4.5 seems to be in this weird middle ground. It's the most expensive model by far, $186,125 compared to $89,625 for O3 Mini. It's slower than the others, and yet it's struggling to prove its worth. OpenAI claims that it's more knowledgeable and it hallucinates less. But when you look at these numbers, you start wondering what you're actually paying for. It's like that restaurant everyone raves about, but when you finally go, you're just sitting there thinking, this is what all the fuss was about? The improvements seem so subjective and hard to pin down that you have to question if the massive price increase is really worth it. Maybe we've hit a point where bigger and more expensive doesn't automatically mean better. This tweet from Andrei Karpathy is honestly a little heartbreaking when you think about it. So imagine that OpenAI releases their shiny new GPT 4.5 model that supposedly costs 10 times more to train than GPT-4. And when they put it to the test in a blind poll, people actually preferred the older model 4 out of 5 questions. It's like spending thousands on upgrading your car only to find out that people liked how it drove before. This is kind of an awkward moment for the engineers who worked on it. What's really fascinating is the disconnect between expert and public opinion. Karpathy, who, if you remember, was on OpenAI's founding team, personally preferred all of GPT 4.5's answers, finding them more nuanced. But regular users weren't feeling it. It reminds me of the fancy restaurants where the chefs create elevated versions of comfort foods that critics love, but actual diners just want the original mac and cheese. When you factor in that GPT 4.5 is significantly more expensive both to use and to run, you start wondering, what's the point? If a company other than OpenAI had released a model with these results, we'd probably call it a flop. But because it's OpenAI, people are trying to find ways to justify what looks like diminishing returns on a massive investment. Maybe we're hitting the ceiling of what throwing more computing power at AI can actually accomplish. These graphs are honestly a perfect visual for the problem that we're seeing with AI right now. See all those downward slopes? They show how AI performance improves as you pump in more computing power, more data, and more parameters, which is basically how complex the AI's brain is. But notice how the improvements follow straight lines going down? That means to get each tiny bit better, you need to multiply your resources by huge amounts. It's like studying for a test where the first hour helps you improve by 20 points. But to get just 5 more points, you need to study for 10 more hours. This is exactly why GPT 4.5 feels so underwhelming, despite costing a fortune to build. The scaling law is hitting us in the face. OpenAI probably spent 10 times more resources to train this model compared to GPT-4, but the improvements are so minimal that the regular users can't even tell the difference and prefer the older version. Sam Altman basically admitted that this is the end of the road for this approach when he said that this is the last model in the classic line. It's like we've been building taller and taller ladders to reach higher, but we've hit the ceiling, and now we got to find a completely different way to keep moving forward. The question isn't whether GPT 4.5 is worth it for users, because clearly they don't think so, but whether this entire approach of just making everything bigger has reached its limit. Sometimes you need to work smarter, not harder. And maybe that's where reasoning models come in. Looking at this chart is kind of a wake-up call. It shows the progress of AI models on a super comprehensive test called MMLU that checks how well they understand everything from math problems to legal questions. At first glance, you might think, wow, we've come so far. From around 25% accuracy in 2020 to nearly 90% now. That's like going from failing every class to being the valedictorian. But notice how the lines flatten out in early 2023, right about here. That's when GPT-4 came out. And basically, nothing has significantly beaten it since. Yes, Claude 3 Opus matched it, and some new models have inched slightly higher, but we're talking tiny improvements. It's like we all waited for the next iPhone to completely revolutionize everything, but instead we got this slightly better camera quality, and that's it. There's so much hype and fear and confusion that it's hard to see clearly what's actually happening. But this chart cuts through all that noise. We've hit some kind of plateau where dumping more money and computing power into these systems isn't giving us the massive leaps that we saw before. And maybe that's okay. These AIs are still incredibly useful, even if they're not reaching superhuman intelligence. But I can't help feeling like we're watching the end of an era. That first explosive growth period is over. And now we're entering a different phase where progress might need to come from completely new approaches, rather than just scaling up what we already have. Okay, this tweet from Vindu Reddy really hits home about what's happening with AI progress right now. It's like watching a reality TV show where the new contestant, GPT-4, shows up with all this hype and flashy promises, but then kind of flops on the actual challenges. Looking at these numbers, GPT-4o is getting 79 out of 96 on successful tasks, while the older GPT-4 got 90 out of 96. That's not progress, that's backsliding. What really gets me is the last line where she writes, "The model is way faster, but it's unclear why it's doing so much more on hard tasks." Frowny face with a tear. It's such an honest admission that even the people building these systems do not fully understand what's happening. This reminds me of when my friend got a fancy new sports car that looked amazing but somehow performed worse than his old reliable sedan. Speed isn't everything if you can't handle the curves, right? And that's what makes the other points about benchmark overfitting so important. These AI companies are basically teaching to the test. They're making their models look good on specific benchmarks that everyone knows about, rather than actually improving core intelligence. It's like if your teacher told you exactly what would be on the final exam so everyone gets an A+, but then nobody can apply those concepts in the real world. When OpenAI's own employees are saying their next big model, Orion or GPT-5, isn't consistently better than previous versions, that's a pretty big deal.
It's like the party's winding down, and we're all standing around wondering what comes next. Are we hitting the limits of what this approach can do? Or do we just need to find a completely different path forward? Either way, it feels like we're at some kind of turning point that nobody quite expected. So, looking at all this data about GPT 4.5, I can't help but see a fascinating parallel with how our own brains work. What's wild is that recent neuroscience research actually shows that important parts of our brains function a lot like these large language models. They're basically token predictors, constantly anticipating what comes next in a conversation. Our brains and AI models both show the same patterns when processing language. When researchers looked at brain activity during language processing, they found that our neural responses match almost perfectly with what happens in transformer models like GPT. The parts of our brains that light up when we're surprised by unexpected words correspond exactly to where AI models would struggle with prediction. Our reading slows down right where AI would be confused too. But here's the crucial difference and why GPT 4.5 hitting a wall matters so much. While language prediction is a huge part of human cognition, it's just one piece of our overall intelligence. A toddler learns a language from way less data than these massive models need. My friend's 3-year-old speaks in complete sentences after hearing maybe a tiny fraction of what GPT 4.5 was trained on. Kids are doing something fundamentally different. They're integrating language with all these other systems: visual processing, motor skills, emotional responses, social understanding. So when we think about pushing AI beyond the scaling wall, beyond just making bigger and more expensive language models, what we're really talking about is adding these other modules. We need to stop thinking about AI development as just pumping more data through bigger models and start thinking about how to create systems that integrate different types of intelligence. What would those other modules need to be? How might we create AI that learns more like a child does, with less data but more integrated understanding? That's where the real breakthroughs are waiting to happen, and that's what we'll explore next. The truth is, there are so many fascinating paths forward that go beyond just making language models bigger. It's like we've been focused on building this one muscle, language prediction, to incredible strength, but now we need to develop the rest of the body. One approach that really excites me is building world models instead of just language models. Researchers like Fei-Fei Li and Yan LeCun are championing this idea, basically teaching AI to understand how the physical world works, not just how language works. This would be like an AI that understands that when you drop something, it falls, or that objects can't move through each other. This kind of common sense understanding is something kids pick up naturally, but our current AI systems struggle with terribly, partially because they're not acting in the real world. Then there's memory, something our brains are amazingly good at. Current AI models have this weird amnesia problem where they can't really remember long conversations properly. Researchers are looking at integrating different types of memory systems: episodic memory, which is your personal experiences; working memory, which is the things that you're actively thinking about; and long-term memory. It's wild how our brains juggle these different memory systems effortlessly, while AI still trips over basic conversations that go on too long. I'm also intrigued by the state of models like Mamba. These are totally different architectures that process information more like how signals flow through circuits rather than how transformers work. They're showing promise for being way more efficient while maintaining performance. Some researchers are even looking back at recurrent neural networks, a technology that predates transformers but might have advantages that we overlooked. And the most promising approach might be cognitive architectures with modular parts. Basically building AI more like how our brains evolved, with specialized modules that work together. Instead of one massive model trying to do everything, you'd have different systems handling different aspects of intelligence. It's like how we have different brain regions for vision, language, motor controls, and emotions. So if this video caught your interest, I would encourage you to continue with my video, Why AI is About to Break Free from Its Shackles. In it, I explore a completely different paradigm for advancing artificial intelligence that goes beyond the scaling limitations that we've discussed today. While we've seen how simply making language models bigger isn't delivering meaningful improvements to anyone, this companion video examines how philosophical insights might be the key to unlocking the next generation of AI. Just as we're now recognizing that neural networks need more than just size to achieve true intelligence, this video reveals how 18th century philosophical concepts could provide the mental framework needed to move beyond current plateaus.